Hello everyone. Today we are going to make a decentralized identity registry on Rootstock. So before diving in, let us understand what is Rootstock. So Rootstock is a smart contract platform that is built on top of the Bitcoin blockchain. It aims to extend Bitcoin's functionality by enabling the execution of smart contracts similar to what Ethereum offers. Rootstock achieved this by utilizing a two-way peg mechanism that allows Bitcoin to be converted into RSK token and vice versa. This integration allows developers to create a decentralized application that benefits from Bitcoin security while leveraging the flexibility of smart contracts. Now let's understand the key features of Rootstock. The first is EVM compatibility. Rootstock is compatible with the Ethereum virtual machine, which allows developers to easily port their existing Ethereum dApps to the Rootstock platform without significant modification. This compatibility fosters a broader ecosystem of decentralized application and services. Smart contracts, other Rootstock supports smart contracts, enabling developers to create a complex application that can automate processes and facilitate transactions without intermediates. Now, let's understand decentralized finance as a DeFi. Rootstock incorporates DeFi functionalities, making it a versatile platform for developers and users alike. Scalability by utilizing the side chains, Rootstock addresses some of the limitations of the Ethereum network, such as high gas fees and low transaction times, providing a robust environment for building and deploying decentralized application. Now, let's go on understanding what is decentralized identity registry. So, identity registry is a blockchain-based system used to record, verify, and manage decentralized identities in a trustless and tamper-proof manner. So the core concept is that on-chain directory or index where key information about DIDs is published and managed without relying on any centralized authority. It does not store personal data itself. Instead, it stores references, metadata, and cryptographic proofs that link an identity to its verifiable credentials. So the key functions are the DID registration, which the users or entities can register their DID accounts on chain. Also, it ensures uniqueness and immutability. Then it's DID resolution, where others can look up a DID to retrieve its associated DID document. Then DID updates and revocation allows identity owners to update or revoke their identity records securely using their private keys. Then we have verification layer, which enables third parties to verify claims or credentials associated with a DID authority without a central authority. So how it works? So first, the user generates a DID and its cryptographic key pair. Then a user publishes the DID document to the decentralized identity registry smart contract. Then the DID can now be resolved by anyone via the registry to verify signatures, credentials, or the connections. So why it's important? Because it's a self-sovereign. Users can fully own and control their identity. Then it's interoperable, which works across multiple ecosystems. It's also tamper-proof, so we can build on blockchain, so identity data cannot be altered by others. And it's privacy preserving, so no personal data is stored directly, only verifiable references are there. Examples that are in practice are the Rootstock, that's RSK DID registry, which stores DIDs on Rootstock blockchain, allowing users to control their identity with Bitcoin security. Then we have Ethereum, which is a similar registries where DID are managed via smart contracts and linked to verifiable credentials. Now we'll be building a decentralized identity registry dApp on Rootstock that will allow the users to create and manage on-chain profiles linked to their wallet addresses. And this is a full stack dApp with a smart contract backend and a modern React frontend. So to build this dApp, we'll require some prerequisites. First one is we need to install Node.js. Node.js is an open source cross-platform JavaScript runtime environment. So you can just click here, get Node.js, and that will be installed. The next you'll require is a Foundry. So this is the website of Foundry. You can give this to the terminal. First, we need to give this link. Then we have to install Forgecast by giving Foundry up, and we have to give this to the terminal. Then we'll require Git. This is the website of Git. You can download Git for Windows, as Git is a open source distributed version control system that is designed to handle everything from small to very large projects with speed and efficiency. So you can just download it for Windows, Mac OS accordingly. Also, will require a code editor. You can choose code editor according to you. We have VS Code cursors. The next thing is we'll require to set up our wallet. For that, we can check out metamask.io. This is the website of metamask.io. You can just click here on Get MetaMask, and you can just add the extension to your Chrome. From Chainlist, this is the website of chainlist.org. You have to search for Rootstock Testnet. So you'll see your Rootstock Testnet, and you can just connect it to wallet. I've already done it. So you can just connect it, and it will be displayed on your MetaMask. Then to take some testnet RBTCs, you just need to go to Faucet. So this is the website of Faucet Rootstock. So here you just copy the address that will be displayed to you in your MetaMask, and just click on Get RBTCs. So you'll get all your test RBTCs there. Then we'll require accounts and services. For that, you can go on Wallet Connect and click here and just log into it, and your project ID will be displayed there. It's quite confidential, so don't share it. Now let's go on implementing our project. So first, I have created the folder rskdid on my cursor. And I'll create two folders here. This first named contract and one more as front end. Okay, so now let's run our terminal cd contract, then forge in it. Just go to git bash here, cd contract, and then forge in it. So it will install all the directories in contract folder. So here it will be displayed. So as we have installed the Foundry, so Foundry is a powerful, fast, and a developer-friendly toolkit for an Ethereum smart contract development written in Rust. So it's similar in purpose to Hardhat or Truffle, but much faster and more modular. So the core tools in Foundry is the first is Forge. So it's for smart contract development like testing and deployment. And we have Cast for interacting with smart contracts and blockchains directly from the command line. Then Envil, a local Ethereum node similar to Hardhat Network or Ganache. And we have Chisel as an interactive solidity REPL. That's a read eval print loop. Now here in contract, we can see foundry.toml, so which is a main config file for compiler version, optimizers, and libraries and paths. Then we have library here, which is a folder for external dependencies, which is installed with Forge install. Then we have Forge standard here, which is a Foundry standard library with testing and scripting utilities. Then SRC. SRC contains all your smart solidity contracts. Then this is the SRC, which we have counter sol, which is an example contract created by default. And then we have test, which is a folder for solidity based unit test, which contains counter.t.sol, which is an example test file for counter dot using false std test. Then we have script, which is a folder for deployment and automation scripts written in solidity. In that we have counter.s.sol, which is an example script to deploy the counter contract. And last we have out, which is an auto-generated after build, which stores compiled ABI and bytecode out. Now let's initialize front end, cd front end. Now let's give the command as npx create next app at latest. So now it will know, it has asked for OK to proceed, so yes. So let's see. Would you like to use TypeScript? Yes or none? Payload CSS? Yes. Source directory? Yes. App router? Yes. Turbo pack? Yes. So import alias? Yes. So would you like? Okay. So now it's installing all the dev dependencies, whatever we have selected. So this Next.js is an open source web development framework that's created by a private company, Vercel, providing a React-based web application with a server-side rendering and static rendering. It's taking time. So React's documentation mentions that Next.js is among recommended tool chains, advising it to the developers when building a server-rendered website with Node.js, where a traditional React app can only render their content in the client-side browser. Next.js extends this functionality to include applications rendered on the server side. Next.js is a React framework that enables several extra features like including server-side rendering and static rendering. Now understand what Tailwind CSS is. That's an utility-first CSS framework for rapidly building modern websites without ever leaving your HTML. So we have added all the packages, and now let's understand what we have got in front end. First, we have is package.json. So package.json defines projects metadata dependencies, scripts. Then we have next config which is the next.js configuration file for custom settings like redirects or env words. Then we have yes config.json, which is a path analysis and compiler options for JavaScript or TypeScript. Then we have git ignore, which is used to specify the files and folders to exclude from git tracking. Then we have readme.md, which is just gives the basic instructions and documentations for your next.js app. Then in public, we have there stores the static assets like images, icons, and robots.txt served directly by the app. Also, in this public, uh, in SR, it's a main source folder containing your app code, which is introduced in this latest next.js version. In app, we have the core uh, directory using the app router. In layout.tsx, it defines root layout, metadata, and global UI. In page.tsx, it's the default homepage component rendered. Then we have styles, then globals.css, global style sheets applied across all the pages. Then we have some modules, and next, which is a built output containing the compiled server and client code. So now we have to delete all the files in src script and test. Even this counter.s.sol, the counter dot, and now we'll create a file in src, which will name it as Decentralized Identity Registry. So let's write SPDX license identifier MID. Then let's write Pragma Solidity 013. Now this is smart contract for managing the decentralized identities on Rootstock. So this contract will allow the users to create and manage all the decentralized profiles linked to their wallet address, strong basic public information on chain. So now let's just define a contract named decentralized DT registry. Now let's give struct profile, which will store all the user's profile information. The string name for displaying the user's name, then string bio for user's biography and description, string of stars, then we'll just define new int 256, create at, which will just give a timestamp when the profile was created. Similarly, I'll have uint 56 updated at, which will just give the timestamp when the profile was last updated. Then I have bool exists, that will the flag to check whether the profile exists or not. Then let's do mapping, which will map from wallet address to our profile, and that will be public profile. Now we'll give an address array, which will store all the registered public addresses. Then again we'll do mapping from address to bool. So this mapping will check if an address is registered or not. So public is registered. Now we'll be defining events for tracking all the profile operations. Profile, which will have our address index user and a string or uint 256 timestamp that we have given already. Again, another event will be created named as profile updated, or that will have address similarly user string and uint 256 timestamp. Another event that will be defining here is event profile deleted, which will have similarly address index user string name uint 256 timestamp. Now we'll define a modifier which will ensure that only the profile owner can modify that profile. So only profile owner, which will have the address of user only, and we'll have require the profile user dot exist, and it will display it as profile does not exist. So now we'll give you a require users exists. I will give you a require Mrs. Dot, and it will display it as only profile owner can perform this action. Then we'll define another modifier as profile exists with an address of the user. Again, we'll write as require profiles user dot exists, and which will display as profile does not exists. This will simply ensure that the profile exists or not. Now let's create a function, create profile. Now in this we'll be creating a new decentralized identity profile with a name of the user, string memory name, with the bio as well as string memory, and the avatar URL, string memory avatar. Now we'll give as external, where we'll write all the required statements. Require profile message dot sender with dot exists, that will display that profile is already exists. Profile already exists. Then the other require the display here is I'll have the byte name with its dot length, which has to be greater than 0, and then it will display as name cannot be empty. Then we have another require. Similarly, we'll give it for the names that are too long. So bytes name whose length has to be less than equal to 100, and that will display it as name is too long. The another will be for bio, where the bio which is too long. So bytes that will have bio whose length has to be less than equal to 500, which will display it as length is too long, like bio's length is too long. The other require will be for avatar, as the avatar The URL also has to be a little smaller than 200. So bytes of that whose length has to be less than equal to 200. I will display it as of that URL. Now we'll give the timestamp uint 256. That will be equal to the block dot timestamp. Now let's write the profiles message dot sender will be equal to the profile, which will include name, the bio, the avatar, and all of those that we have defined earlier. Avatar, then in created avatar, then we have created at for created at we have the timestamp or updated at times. This will be true. Now we'll give a loop. So we'll have an if statement. So is there to add the register address if it's not already registered? So we'll write is registered with message dot registered addresses dot push. In that we'll have our message dot sender. Then is registered. Now we'll give another command as emit proof created with message its name and the times. Now as we have updated the existing profile, now we'll have a function called as updated profile in which we'll give the name, bio, and of that similarly. So another function as update profile, and we'll give the string memory name, string memory bio, and we'll have string memory of the now we'll give as external. We will have the profile exists message dot send. Now we'll define here the length require whose length we want more than 0. The length has to be greater than 0. If it is, then it will display as name cannot be empty. Similarly, the requires statement for name's limit, which will be the length has to be less than equal to 100. If it is, then it will display as name to law. Then another require for on bio. So bytes and that will have bio whose length has to be less than equal to 500. If it is so, it will display as bio too long. Similarly, for avatar, we'll write this avatar whose length has to be less than equal to 200. Then it will display it as avatar URL is too long. We'll give our uint 256 timestamp, which will block dot timestamp. Now we'll create profiles dot message dot sender and that. Similarly, we have to write this for bio, avatar, and timestamp. Message dot sender dot and the final one will be for time files dot this message dot sender dot updated as this one is for updating our profile, the timestamp. Then we'll give a emit the profile updated in which we'll give the sender's message, the name and the timestamp allotted and it's updated. So we'll give another function now as update name, which will update only the name of the profile, which will display a new name. So function as update name with a string memory and an external profile exists. I'll just start and out. Now I'll give our require statements with the bytes name whose length has to be greater than 0. Whose length has to be greater than 0. Then we'll give it as name cannot be empty. Name whose length has to be less than equal to 100. If it is so, then it will give it as name to long. Now we'll give it as profiles. Is dot center dot name, which will give its name. Then profile, which will give it as updated at and the timestamp at which it has been updated. Updated at with the logout timestamp. And now I will give the command will give it as emit updated message dot sender the name and the timestamp. Now we'll create another function for deleting the profile. Delete profile. So this will just delete a profile and set exists to false. So similarly, we'll give the external profile exists the sender, and here the profile will just set it to false. So profiles mess.sender.exists should be false. Now let's give emit profiles deleted, profiles deleted, message dot sender and the log timestamp. So now we'll give another function named as get profile. So this function will give the information for the given address. So that's right. And this will help the users to get the profile for any data. So address user terminal view written. So it will give the profile memory in which will give require profiles with user exist, and then this will display as profile does not exist. File does not exist. And then it will return profiles. It will return. Now we'll define one more function has profile address user. So this has profile will check if a profile that exists for a given address, and the user to check the address will give an external view returns. So in 256, a written registered address length, registered address dot. The another function that we'll be defining here, it has functions get total profiles. So functions get total profile. The external view returns, it will give UN 256. It will give a return registered address dot length. The next function we have is source profile by name, in which we can search all the profiles by its name. It's obviously a case sensitive. So function search by name in memory search term, then external view returns the address memory. Now we'll give a require bytes. It will have the search term, whatever will search the profile by its name. It's search term whose length obviously has to be greater than zero, and then it will display as search term cannot be empty. Then now we'll have count matches first. So UN 256 match count, which is initialized to 0 first. Then for UN 56, first we'll for UN 256, we'll name it as I and we'll initialize it to 0 first. And this I has to be less than the registered addresses dot length with, then we'll give address user as registered addresses I, and create if the profile user exists, and also the string contains with its name and the search term. Then the match count will have an increment. Now let's create a result array. So let's give memory memory, and the matches is equal to the new address in the match count. Now we have this UN 256 as index and we'll initialize it to 0 first and we'll give a for loop with I as 0 and this I has to be less than the registered address length increment and the address will be registered addresses I now I will give if the profiles user exists also if the string contains the user with its name and search term then the matches index would be user self and then index. Here we'll return our matches. Okay, so here we have completed our smart contract. We'll create our deployment script. So let's go and script here and create a new file named as deploy decentralized identity registry. Deploy decentralized identity registry. It's dot right. So now let's write the deployment script here in this. Let's begin with SP license identifier MID. Then we'll give a pragma solidity point 13 and then we'll have your import that will importing the founder script utilizes and console for logging. So import script and console. We're importing this std and then that will have script dot now we'll have again import that will be importing our decentralized identity registry and it will be importing it from the source. This will in short import the decentralized identity registry contract to deploy. It will import it from RC decentralized identity registry dot. Now we'll here create a contract. It will name it as deploy decentralized identity registry. Deploy decentralized identity registry. So this will have this Foundry script that will deploy the decentralized identity registry smart contract on a chosen network. Write the function here. Function with an external. Now we'll give a string memory, private key string. And we'll have the private key in this. So the private key is stored in the env file as private underscore key. Dot env string. It will be stored in the env file as private underscore. So this will load the private key from environment variable. Deploy as private key. Deploy your private key. So it will pass the string to int 256 and prefix it with 0x. String dot concat 0x. This will just prefix this x in front of the private key string. Next, we'll have the address deployer. Then we'll have the deployer's address. So console.log. It will write it as deployer's address and will display the deployer's address there. Deploy here. We are done writing the deployment script. Now let's see Foundry terminal. Public hive node dot rsk dot co. And then we'll have the etherscan. So etherscan with rootstock testnet, and its key is equal to the rootstock API key. So we'll have the rootstock API key and we'll give the URL to it. URL will be https://api.explorer dot testnet dot rsk dot co/API. So here we have updated our foundry.toml. Now as we have written a smart contract and script, now let's go on deploying our smart contract. So open terminal and open git bash init. Give a command cd contract. Then export your private key. So export private underscore key and just mention your private key in this as confidential. So I will not mention it here. Then go on giving a forge command. So forge script Then deploy decentralized identity registry.s.soul, and then give RP URL rootstock and then cast. You can just write this command in your terminal, and this will just go on compilation, and it will deploy our smart contract. So this will tell the Foundry to run a script that is written in Solidity. So you can see your script ran successfully, and you can just see all the information here, the deploying contracts with the account balance, and where this decentralized identity registry is deployed to, and then it have verified at deployment. The contact address, deployer address can be seen here. So just save this contact address and the ABI key, as will require it further for integrating with the front end. So it has just done a verification and our script has run successfully. So yes, so save this contract address from here. The deployer's address can also be seen here. And here we have completed the on-chain execution successfully. And here is the transaction saved. You can see the contact address and everything here. So in this video, we have successfully deployed our contract. And in the next part of this video, we'll be integrating with the front end and we'll be writing all of the codes of front end. So till then, thank you. Happy coding.